Alright, T1 equals 95 newtons. T2 is 115 newtons. This is just like what we did in class. So I have a T2x here. I have a T2y. It's a big old angle right there. Let's get T2x. That's adjacent. So I'm going to come up here and go cosine of 37 equals adjacent, which is T2x, divided by hypotenuse, which is 115. Multiply those, 115 times the cosine of 37. T2x equals 91.8. 91.8. At this point, I can get T2y. Any way you want. I'll do sine though. Sine of 37 equals opposite, which is T2y, divided by hypotenuse, and it's going to be 115 newtons times the sine of 37 equals T2y. We get T2y equaling 69.2 newtons. Now, I need a T3x over here. Since there's only two x components, it has to equal the other side. This is almost exactly what we did the other day. However, I can't make that assumption with the y. I have to go to sum of the forces in the y direction equals 0. I have 95 newtons up. I have minus T2y, which is 69.2 newtons. And I also have a, whoops, I never identified this as T3y, minus T3y, this equals 0. So negative T3y equals negative 95 plus 69.2. I'm going to get negative 25.8 newtons. When they're both negative, they're both positive. So T3y is 25.8 newtons. Now I've got an a squared, b squared this to get T3. So 91.8 newtons squared plus 25.8 newtons squared equals c squared. Let's throw that in our calculator. Square root answer, and I get 95.4 newtons right there. And I'm kind of running out of room here, and I kind of want to leave it big. So I'm going to come over here to solve for this angle. I can go to another color. The angle, I don't care which one you use, any one will work. Let's go sine of the angle equals opposite, which is 25.8 newtons, divided by hypotenuse, which is 95.4 newtons, but by to newtons, the angle, boy this is getting messy, is inverse sine of 25.8 divided by 95.4, and throw that in your calculator. 25.8 divided by 95.4. I get an angle of 15.7 degrees. Woo woo.